Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our lesson number 97. Lesson number 97. We are at this stage in the game in our semester. Day number 86 through 100. We've been learning how to solve linear equations. And today is day number 97. Let's see what we have for today. We are told that 2x over 5 plus 3x over 6 equals 1/2 plus x minus 1. And of course our job is to find out what value of x will satisfy this equation. First thing first. First thing we have to realize is that we have a denominator of 5 here, a denominator of 6 here, a denominator of 2 there, and a denominator of 1 here. They all have different denominators. We need to find a common denominator, or to be more precise, the least common denominator. Do you understand? What's going to be the least common denominator of these numbers? Well, let's find out. We have a 5, a 6, and a 2. As long as we can divide two numbers out of these three, we can do that. So if we divide by 2, 5 just comes out because 5 cannot be divided by 2. 6 divided by 2 is 3, and 2 divided by 2 is 1. There you go, that's your common denominator. The common denominator is going to be, the least common denominator that is going to be 2 times 5 times 3 times 1. 2 times 5 is 10, 10 times 3 is 30. That's the common denominator here. The least common denominator is 30. Now the question is, this guy has a denominator of 5. How do I make it 30? How do we make this, how do we convert this 5 into a 30? Well, multiply top and the bottom by 6. Now it is 30. This guy has a denominator of 6. How do we convert that into 30? Multiply top and the bottom by 5. Voila. This guy has a denominator of 2. How do we convert that into 30? Well, multiply the top and the bottom by 15. This guy has only a denominator of 1. We need a denominator of 30. Well, multiply the top and the bottom by 30. Voila. Now, everything has a denominator of 30. 6 plus 5 is 30. 5 plus 6 is 30. 15 times 2 is 30. And 30 times 1 is 13. Everything has a denominator of 30. And since every single term throughout the entire equation has the same denominator, that denominator no longer plays any part. It has lost significance. For example, 120 over 30 minus 90 over 30 is 1. Would you agree? 120 divided by 30 is 4. 90 divided by 30 is 3. 4 minus 3 is 1. This has a denominator of 30. This has a denominator of 30. This has a denominator of 1. How do we make a common denominator? How do we give this guy same denominator as these two guys have? Well, multiply the top and the bottom by 30. Voila. Now, this has a denominator of 30. This has a denominator of 30. And this has a denominator of 30. 1 times 30 is 30. It has a denominator of 30. Since every single term in this equation, throughout this entire equation, has the same common denominator, that denominator no longer plays any part. It has ceased to play any significant role. It plays no role at all. We can ignore it. Watch here. If we ignore it, it will still be a valid equation. 120 minus 90 equals 1 times 30. You see? It has lost its significance. Same exact thing has happened here. 30 plays no role. The 30 at the bottom plays no role. We can simply ignore it. So 2 times 6 is 12. 12x. 6 times 2x. 6 times 2x is 12x. Then we have 5 times 3x. 5 times 3x is 15x. We are told that equals 15 times 1, which is 15, and 30 plus 30 times x minus 1. Let's open this parenthesis. We get 30 times x is 30x, and 30 times negative 1 is negative 30. How much is 12x plus 15x? Well, 10x plus 15x would be 25x, and the 2 would give us 27x. Let's bring, and then here we have positive 15 and a negative 30. A positive 15 and a negative 30 gives us, here is our 30x, positive 15 and negative 30 gives us negative 15. Let's bring this 27 on this side, and what do I mean by that? Let's bring this 27 on that side. That's just a very fancy way of saying let's subtract 27x from both sides. Voila. I have brought it on this side, and by the virtue of crossing the equal sign, whatever sign it had before, it becomes the opposite sign. So now positive 27x and a negative 27x cancel out, and this actually reappears on this side with the opposite sign. So what do we have on this side then? We crossed out everything. It's just a big fat 0. 0 equals 30x minus 27x gives us 3x minus 15. Let's bring this 15 on that side. What does that mean? Bring 15 on that side. It's just another fancy way of saying let's add positive 15 to it. So negative 15, positive 15 cancel out, and here we end up with 15 equals 3x. You see? We brought this negative 15 on this side, and by virtue of crossing the equal sign, the negative becomes positive. When you cross the equal sign, the signs switch sides. The signs will switch sides. Let me give you a quick example of what I just said. For example, would you agree that 3 plus 4 equals 7? Would you agree that 3 plus 4 equals 7? Of course you would. Why wouldn't you? You would have to be insane not to. I'm going to bring 4 to the other side. So now it says 3 equals 7. I'm going to bring the 4 to the other side, and this positive 4 becomes negative 4. So now it says 3 equals 7 minus 4. Of course it does. You see? Now we got to divide both sides by 3 to get rid of this 3 here, and x equals 15 over 3, which is 5. And finally, we're going to honor the tradition, the convention. The tradition dictates that we put the x, the unknown, on the left hand side and the known quantity on the right hand side. It is much better to say x equals 5 rather than saying 5 equals x, because it is not the 5 that equals x, it is the x that we have found out to be equal to 5. The very last thing we need to do at this point is to substitute the value of x back in our equation and see if it satisfies the equation. In order for us to do that, it will make our life much easier if we leave the equation in its original form. Let's cross out everything, erase everything extra that we put in there. Let's leave the equation in its original form. I just realized, is that how it was given, 3x over 6? Well, it is. It's insane. Whoever made this question was insane. Person who should not be named. Because you see 3x over 6, I could have simply put there x over 2. I don't know why I put 3x over 6. The very first thing we should have done is convert this 3x over 6 into x over 2. And the equation actually would have been much simpler, because if we had 2, we would have had a common denominator of 10. Anyway, let's put it back in. X equals 5. Let's put it back in here. X equals 5. 2 times 5 is 10. 10 divided by 5 is 2. X equals 5. 3 times 5 is 15. 15 divided by 6. Ah, that's a tricky one. 15 divided by 6. Which is same as, well, we know that 12 divided by 6 is 2. So this is 2.5. So here we get 2 and 2.5, 4.5. We have a half already here. This better be 4. Well, there you go. X equals 5. 5 minus 1 equals 4. 5 minus 1 will give us 4. So 5 minus 1 is 4, and another half makes it 4.5. This is 2 and this is 2.5. 15 over 6 is 2.5. It fits. It works fine. That was the end of our day for day number 97. What I'm going to do now, I don't know if I want to go there or not. What I want to do is actually, usually I end these videos at this point. What I'm going to do is go back and redo this problem, because this is insanity. We should have seen this before. We should have noticed it before, that 3x over 6. We can divide top and bottom by 3 and make our life simpler. It should simply say x over 2. X over 2 and a 5, it gives a denominator of 10. I want to redo it with the denominator of 10 and see what we get. Okay? But I'm not going to explain everything. We're just going to do it very quickly. Redo it. As I said, I'm not going to explain any steps. We're just going to redo it. We've done many of them. You know how to handle this. Is half. This is x minus 1. And this is how it's given to us. So, 3x over 6. If you divide the top and the bottom by 3, 3 divided by 3 is 1, and 3 divided by 6 is 2. So it's just x over 2. So we can replace this guy with x over 2. Two x over 5 plus x over 2 equals 1/2 plus x minus 1. We need a common denominator of 10. We need a common denominator of 10. There we go. Now we have a common denominator of 10. 2 times 2 is 4, so that's the 4x. 4x. 5 times x is 5x. 5 times 1 is 5. 10 times x is 10x. And 10 times minus 1 is negative 10. Let's see what we get there. This is 10x. 4x plus 5x is 9x. 5 minus 10 is, so we get 10x. 5 minus the 10 is minus 5. Bring the 5 to this side, bring 9x to this side. In other words, this is what we're going to do. We're going to do 2 steps together. We're going to add 5s to both sides. And at the same time, we're going to do 2 steps together. Subtract 9x from both sides. Voila. So this positive 9x and a negative 9x cancel out. This negative 5 and positive 5 cancel out. 10x minus 9x is x equals 5. Voila. X equals 5. So we did it one more time, a little bit differently. That's all. We should have noticed this thing. 3 and 6 is... If you can reduce the equation right off the bat, right away, before you do any work, go ahead and do that, because it will create less work for you down the road. Do you understand? I will see you tomorrow. So even through the mistakes we learn things, because that's not how I meant to make the equation. I don't know how it came out like that, and I didn't notice it until now. But it's a good thing. We get to do it twice. I will see you tomorrow on day number 98. Alright? Bye now.